Okay. So we're in lesson 5-6, and we're going to be talking about graphing linear inequalities. So we're going to, a couple things to keep in mind. We're going to graph as if it were a line, as if it were a linear equation. We have two methods that we used for graphing linear equations. Number one would be making sure the equation is in slope-intercept form. Intercept form. Which is y equals mx plus b. So remember that chart I gave you yesterday, Michael?
Could you also, just for graphing, could you change it to standard form?
Okay, you didn't let me finish. I said we had two strategies. This is strategy one. So m represents the slope and b represents the y-intercept. So when you graph the y-intercept, it needs to be on the y-axis. Again, I saw a lot of issues with that. So you can write it this way if you wanted to as an ordered pair. Okay. The second strategy that we talked about was if it's given to you in standard form, which looks like ax plus by equals c. Notice that m and little b don't show up. There's a difference between a big B and a little b. Big B is a coefficient. Little b is the y-intercept, so they don't mean the same thing. Notice no slope, no m. So it doesn't reveal slope and it doesn't reveal the y-intercept when it's written in standard form. So what you're going to do is solve ax equals c for the x-intercept. And the reason why we do that, why the y disappears, is because the x-intercept has a y-coordinate of 0. And then we're going to solve that by equals c for the y-intercept. And again, the reason why we can do that is because the y-intercept has an x-coordinate of 0. So that's going to help us get what our graph is going to look like. But we can't just willy-nilly start graphing. We actually have to take in mind the inequality. So the inequality has an effect on the line. Okay. So we have and remember how we kind of grouped inequalities several different ways when we were first taking our notes, if it's open or closed, if it's right or left, they kind of group up different directions, okay? So the same sort of thing happens for us, even on inequalities. So if you have an inequality that's a greater than or a less than, when we were doing our inequalities with the single variable, that meant the number we got was not a solution. And we used an open circle. So our open circle that we were used to with the one variable now becomes a dashed line. And again, the reason for this is that the points on the line are not solutions. And then we have greater than or equal to or less than or equal to. So remember that was like a closed circle, which said, yep, that number is one of the answers. Oh, that looks terrible. So what we're going to do is get a solid line. So we're going to draw it just like we did with linear equations. And again, what this means is the points on the line are solutions. Okay, but that's just the line itself. What we haven't done is color a direction. When we were doing the linear inequality, or the inequalities, excuse me, in the beginning of the chapter, we had to color right or left based on the inequality. Now that we're graphing in coordinate plane, we have to graph half of this graph. Okay, so the inequality has effect on what half of the graph we color in. Now that half gets a name, so I'm going to give you that. Is everybody ready? And actually, we can say that this line that we're going to be graphing is called a boundary line. So I'm going to add that little word in here. This is a boundary line. So the line I draw is called a boundary line. So it is either the top or the bottom of all the solutions, depending on whether we graph above it or we graph below it. Okay? So let's talk about the next word. So the next thing we have is called a half plane. And linear inequalities also color in either above the line or below the line. And again, the line I'm referring to is that boundary line that we've already put in. Okay? So let's go back to our inequalities. So if now they group a different way. If they're greater than or equal to, generally speaking, those are the more positive things, so we want to graph above. Because, you know, heaven's a high. That's a positive place, right? So we're going to color the half plane above the boundary line. Without coloring, your graph is not right. Now, what's interesting is that you don't mathematically, you have no set builder notation how you write the answer. Okay, you don't do that. It's only the graph that is the solution. That's a big difference and a big key, whether you're doing on a number line or on a coordinate plane, is if it says graph the solution is the only directions. If the other directions say solve the inequality, then graph, they usually say on a number line. That's your connection. Oh, it's back to the easy ones that we did in the beginning of the chapter. So if we go the other direction now, less than or equal to, we're going to color the half plane below the boundary line. Okay. Now again, coloring is kind of hard to get rid of, and so we want to make sure that we're coloring appropriately. So you have two lines of thought, and I'm going to tell you I'm going to only share one of them in our notes, but I'll talk about both of them. The two lines of thought are this. You first establish whether you think you should be graphing above or below. One line of thought is, if you think you're supposed to be graphing above, find a point that's above your line. Test that point. If you get something that's true, then you are accurate. That's where you're going to graph. Okay? If you test that point and you get a false, then you graph the other half. And you had a wrong guess as to which half you were going to do. I think what I like better is to pick the same sort of point every time. And based on its answer, it's telling you if you get, no, this isn't true, then you don't graph where that point was. Yes, it's true, then you graph where that point was. So for me, that's the strategy I like using better, because then I'm always picking the same sorts of points. So you want to test before coloring. Because next unit, now we're going to do a system. We're going to have two linear inequalities, and you need to see where they overlap. So this is why testing first is so important. So test small points like 0, 0, or 1, 1, or 1, 0, or 1, 1, or 0, 1. So here's the big key about this. Test point cannot be on the line. So what we're going to do is substitute this point into our linear inequality. Substitute the point into the linear equality. If true, and remember true means what's on the left has the relationship that the inequality says with the number on the right. So it's not as simple as it equals, because in the equations it was 5 equals 5. Yes, that's true. This one, it could be 5 is less than 4. False. Could be 7 is greater than 1. Yes, true. Okay, so it just kind of depends on the problem. So if true, color the half that includes the point. If false, color the half that excludes that point. Okay? So testing, again, super, super important for us to understand. Test that point before you shade. Okay, so the directions that you will be hearing are going to say, let me see, I'm looking at graph each inequality, use a graph to solve. So it just basically is very simple. It's either going to say graph the inequality. So again, I'm just listing both sets of directions that mean it's going to be in a coordinate plane. Graph the inequality, or it could say use a graph to solve. Use a graph to solve the inequality. With the simple inequalities in one variable that we talked about in the first 3 lessons, honestly, the graph was not the most important part. It was actually solving the inequality and writing it in set builder notation. This is the only solution, is the graph. So definitely need graph paper tonight. So I'm going to give you a suggestion that I think the better way to go with these, if it's not written in standard form, is to go with standard form. And here's my reason for that. If you try to do intercepts, like particularly on this one, what's the x-intercept? 2/3. You're graphing a fraction. Okay? So my suggestion is go into slope-intercept form, because if you get a fraction, generally speaking, it's going to be your slope, which you want to be a fraction. So let's go ahead and solve this into slope-intercept form. To do that, we're going to get y alone, so I subtract 3x from both sides. Notice that's not going to change my inequality. That leaves me with negative y is less than negative 3x plus 2. And then we're going to divide everything by negative 1. Ooh, inequality will flip. And that gives me y is greater than 3x minus 2. Now I'm going to identify my key pieces. What's my slope? 3. And remember, we're going to make it a fraction, so we'll make it 3 over 1. And what's the y-intercept? -2. All right, now notice that I didn't even think about looking at the inequality until I had put it in its final form. Okay? And I'm not going to get that with standard form. Standard form just will help me figure out intercepts, but it's not going to help me with my inequality. So the only way to get my inequality correct is putting it into slope-intercept form. So now I'm going to analyze what that tells me to do. So will my line be solid or dashed with greater than? Dashed. It says the answers on those points on the line are not part of it. Now, should I shade above or below? Above, because it's positive, okay? Because it's greater than. So here's what I'm going to do. I'm going to test 0, 0. And I'm going to go back to the original equation and see what I get. 3 times 0 minus, 0 less than 2. So is 0 less than 2?
Yes.
Yes, that's true. So what that says is when I graph, I'm going to shade where 0, 0 is. So that's confirmation how I'm going to do my shading. Okay? So I've done all this prep work and I'm ready to graph.
Don't you test after you graph the 2
Nope.
points?
You don't have to. I would do it. You can do it either before or after you graph your line.
Like, what if you don't know 0, 0 is not in the graph?
That's true. That's true. You usually get something weird when you test a point that's on the line. You get what the number on the left is the same as the number on the right, and then you can't figure out the inequality because it doesn't make sense. So you're right. Probably ideal would be to wait. Okay, so I'm going to graph where, let's see, the y-intercept is -2, and then I'm going to rise 1, 2, 3 up and to the right 1. Remember, puff, puff, positive, it was a positive slope, so and I didn't dash it. You still want to use a ruler of some sort. Now, it told me that I should shade above, and when I shade above, it should be passing through 0, 0, which confirms, yeah. So then all I do is shade like this. I just kind of make hash marks. Okay? And that's what you're going to be working on the homework tonight. So you do need graph paper. And I gave you one extra problem. Oh, I think I need to change the homework assignment. All right, so this is what you're going to be doing on your homework tonight.